the statement, the square of any rational number is rational, can be rewritten formally as, for all rational numbers x, x squared is rational, or as, for all x, if x is rational, then x squared is rational. Rewrite each of the following statements in the two forms, for all blank x, blank, and for all x, if blank, then blank, or in the two forms, for all x and y, blank, and for all x and y, if blank, then blank. So part A, the reciprocal of any non-zero fraction is a fraction. So the word any is being applied to non-zero fractions. So we would say, for all non-zero fractions x, the reciprocal of x is a fraction. So that means 1 over x is a fraction. Another way of saying this is that for all x, if x is a non-zero fraction, then 1 over x is a fraction. So those are two ways of saying the same thing. Part B, the derivative of any polynomial function is a polynomial function. So we're making a claim about any polynomial function. So for all polynomial functions x. Now what about polynomial functions? Well, the derivative of those polynomial functions is a polynomial function. So the derivative of x, I'll put x prime, is a polynomial function. Another way of saying this is that for all x, if x is a polynomial function, then x prime is a polynomial function. For part C, the sum of the angles of any triangle is 180 degrees. So the universal quantification is on triangles. So for all triangles x, the sum of the angles of x is 180. Put another way, for all x, if x is a triangle, then the sum of the angles of x equals 180 degrees. And just to save space, this right here goes right here. For part D, the negative of any irrational number is irrational. So the any is being applied to irrational numbers. So for all irrational numbers x. Now what about the irrational number x? Well, the negative of that number is irrational. So negative x is irrational. Put another way, for all x, if x is irrational, then negative x is irrational. For part E, the sum of any two even integers is even. So any two even integers, we're quantifying universally two even integers. So for all even integers, and we need two of them, so x and y, the sum is even. So x plus y is even. Put another way, for all x and y, if x and y are even integers, then x plus y is even. And then last is part F. The product of any two fractions is a fraction. We're universally quantifying two fractions. So just like part E, for all fractions, but we need two of them, so we're going to put an x and a y. The product is a fraction, which means xy, x times y, is a fraction. Put another way, for all x and y, if x and y are fractions, x times y is a fraction. Thanks, everyone, and I'll see you in the next video.